Hey there, hello, anyone out there looking for some data on a Saturday afternoon or whenever you happen to be watching this. My name is Carl, I'm a data scientist, and I live stream sometimes with some excellent music in the background. But without further ado, we're going to do some churn analysis with regression in today's live stream. But without data, what can you do? So I'm going to start by just getting the data that we need here. Excuse me for whipping this stuff around, but I haven't streamed for a while, had a few issues getting started today. But let's just get into the code and let's extract some data. I went into my IDE environment here and I ran the script LiveProject dataset. Just going to start out by showing you all where the data is from. This is actually rerun from previous streams. Let's see, am I live here? Not quite. Waiting to hit my first breakpoint. But yeah, so this is rerunning some stuff from last stream, or previous streams, I should say. It's been actually a few months now since I did this. But this is going to get us the data set. And why are we connected but nothing's happening? Finally, okay, finally hit my breakpoint here. You know, I try to get to the code fast, but you know, I should have like pre-launched even, so it could have done the startup. So I have some Boolean flags here to get to the right portion of my code. I can do either a current data set or a past data set. We're going to go right to the past data set. So this is from 2020-0101 to 2020-0301. So this is a couple years old now. Funny how time flies. And I'm going to run this step called SQL listing. It's going to run a SQL and I'm going to print it out on the console. I'm just going to step over this because it's going to print out what it does, and then we can actually take a look at it. It's actually not so easy to see in this viewer, but it's executing this SQL, which has this very funny structure shown here. Select account ID, observation date, and a variable churn. And it has these funny some case when statements. So what's going on here? I actually have a little explanation prepared for this. This is doing what's called flattening a data set. I've got a bunch of data. Let me go back to the slide deck here, and we'll hit into this one. I've got a bunch of data in a tall table called the metric table. And there's measurements like logins per month, posts per month, likes per month, and stuff like that. And they have their values. And to make a data set, we need to flatten the data, which is putting it in this wide format shown here, where each account has the metrics spread out along one row, one metric per column. So back to the SQL, that is actually what we're doing here. We do, a better way to look at this SQL would actually be if I go to the listing. Let me dive in and I can open it up properly. I think this was, what are we doing? Chapter 5, the data set, or no, 4, sorry, chapter 4. You can see here, we have these sum case statements. It's a sum with a case on the inside. So the case statement only picks out one metric for each field because it's selecting by the metric ID, and then we do 0 otherwise. And with the combination of the sum and the case statement, it actually achieves the data flattening that I was just talking about. So we go from this metric table in a tall format to a wide format in the data set using this special SQL. And we're also doing an inner join to select the right records. And if we go through, this means we've run our SQL, and I'm just going back to the console printout of the script. It says we're saving it in this LiveProject dataset file. So let me get back to my debugger, and we'll go back to, we're still in this script here. I just used this utility function, SQL listing, to actually run the SQL against the database. Now I'm going to measure the statistics of the dataset with another listing, dataset stats. And we'll go in here And the first line here just does a good validation sanity check on the path. Make sure that the path is a file. Then we read it in using pandas. This is PD. For those of you who don't know, good old pandas, the workhorse of data science, or the work bear of data science in Python. A lot of animals in Python. Pythons, pandas. Anyway, so we do read CSV, and I'm specifying the index column is from the first two columns. And now we can actually look at the data set that I created using the debugger. Let's see, view as data frame. This actually might take a minute. Might even crash my computer. Oh, maybe I clicked it too fast there. Oh wait, now it's working. All right, now we can see the data set. And this shows us on each row, we have a customer ID, a flag for if they churned or not, and then all these metrics of like what they did. This is with an ebook reading website. And I'll tell you more about that in a minute. But so we pulled up the data set. And next we are going to make some statistics on it. I turn the churn indicator into a float here, so when I take the average of it, it'll give me the churn rate, which is the percentage of churns. And here I'm going to use one of the best methods of pandas data frames, describe. Describe method in one shot gives you a nice summary of your data. Let's take a look at that. In a data frame, of course. So I can see the count of values, the mean, standard deviation, min, and these quartiles, I guess, min, max, and quartiles of all the metrics in the data set. So you can see that reading their books, the mean is 17 reads. Ebook downloads, the mean is 3.4. The max is 503. That's a lot of downloads for a book. Anyway, so that's what we've got in the data set here. And that, again, the describe method, a great way to get a summary of your data, a must-have in every data scientist toolkit. And here I take the transpose because I want to turn it sideways. And I also do a few other statistics. I like to look at the skew, the first and 99th percentile, and the percentage of non-zero metrics is this little expression here. I don't want to spend too much time in it. If someone has a question on the chat, throw it out. But I'm trying to get through this quick because this is meant to be the review. So finally, I have resorted my summary and turned it sideways to how I like to look at it. So let's look at it in the debugger again. So now I have all of my measurements on the rows, and I have the count, the percentage non-zero. You can see 69% churn. It's kind of bad, but it's retail, so it's actually not that bad. And it's also quarterly churn, so it's much less per month, for example. All right, so this is the data set that I'm working with, and we're going to be working with it through the rest of the stream. So that's why I'm starting out the stream showing you where I'm getting the data. Now, we created this data in much earlier streams. I'm not going to go back to how I created it, but this gives you an idea of what are all the metrics we've got. Search made. You can see a lot of these metrics are pretty rare in that not that many customers have them. Only around 7% made a search. Only 7% looked inside a link open. All these good things. But so these are the features or metrics in the data set, and I just wanted to start out by showing them and start out with a little code. And this is also going to save the results. Last line of this script. Print that we save the results to this place, which is a local path for me. So that is the quick code opening for the stream. We got the data set, and now we're going to do something with it. I'm going to back up for a second and give some of my background in case for any of you this is your first stream with me or the first video you watch of me. You never know. I talk a lot about churn, so I'll start out with what is churn? And churn is when subscribers, customers, or users quit, unsubscribe, unfollow, cancel, whatever. The bad thing you don't want to do. So don't unfollow me. You know, I can't take the churn. Just kidding. I can take it. Origin of the term churn is from the churn rate, which refers to a percentage of customers that are dropping out. And churn is also now a verb. You can say the customer churned or I churned. from a subscription. Like I churned from Netflix because I got sick of, you know, Peaky Blinders or whatever I was watching on Netflix. I don't know. On Netflix, I'm currently watching The Imitation Game, and I'm not sick of it, so I'm not canceling my Netflix or churning from Netflix. You can also use churn as a noun and say like, make a churn report or make a report of last quarter's churns. So that's what we're talking about. But what we really want to talk about is data-driven churn reduction. The first way to reduce churn is to make a great product, right? If people like your product, they don't churn. The next way to reduce churn is targeted marketing. Also, you can help your customers succeed with proactive and reactive assistance. And you can fix your sales and pricing, all using your data. So that's kind of really what we're trying to do when we talk about churn. It's not an abstract problem, it's a practical problem. Why learn about churn? Well, I like to say churn is the most common data science problem in the world today because every business now wants their customers to keep coming back, which means every business wants their customers to not churn. So every business now has a churn problem, even retail, because even retailers, they want repeat business, right? And we're actually looking at a retail case study today. Also, churn is a great way to learn data science foundations because churn is what you would call a binary, outcome, just the classic data science problem. But also by working on churn, it's a great way to go from raw data to actionable results. So, how are we going to learn churn today? It is fighting churn with Manning's LiveBook data, a live project with online learning from a real data, which is actually Manning's own data. It's Manning Publications' own book selling and ebook reading website that we're analyzing the real data from. Now, it's very hard to get real data for your data science education, in case you haven't noticed. Real data can be hard to come by. So this is a cool opportunity to get your hands on some real data. Unfortunately, it's not free. Sorry, publishers have to make money. Data scientists like me, I don't need your money from this, so seriously. But my publisher really could. So if you want to buy it, here's the link, and there's a discount code also. You can always get this discount code in my streams, 35% off whatever they tell you on the website. So let's finally look at the project. And oh my God, I actually don't have my web browser ready. So we're going to look at the live project number 3 in this series. Live project number 3. And I'm going to go to it in just a sec. I had a little restart problem with my computer before this stream. I was like, okay, I'm just gonna, my uptime was like 6 days at this point, and I felt like it was time to do a restart. So, God. Yeah, so when I was restarting right before doing the stream, and then Apple caught me with that, oh, do you mind if we refresh your system? So I was not really ready for this, this stream to be happening today. So I'm gonna have to get signed in right now to, I'm gonna get signed into the Manning website, and I'm gonna show you the project if this thing will comply by minimizing so I can get another screen out. Here we go. This is what I really want to show you. This is what you'll be seeing if you've actually, made a login for the, the Manning LiveProject website. So here, let's see, Live Project. Oh no, I scroll down. Here's where I find my projects. God, if I can even see it here. Yeah, I'm not getting too much love from the system today. I don't know if it's Mercury in retrograde or what. But so this is what you'll see if you're in the live project, and we're going to project 3, I said. Here, let me get this back into presentation mode so I can show you that. Project 3, churn forecasting, milestone 2, regression. Here we go. And my little 500 error popping up. So this is what you see when you go into the project, milestone 2. So we are now going to not go to that part. We're going to start here. we are looking at this logistic regression, statistical forecasting, and analysis milestone. So I'm just going to read it, and then, well, I'm going to give you an overview. I'm not going to read the whole thing, and then we'll like dive in. Okay, your boss at Manning liked the work you did with the machine learning algorithm, but still had some questions. Now that's referring back to the last milestone, which was analyzing the data set with the machine learning algorithm. So our boss, they found the explanation a little hard to follow. And weren't sure if the accuracy was good or not. So they asked you to fit a logistic regression model to the data because they heard that it's the most interpretable model and it's a good baseline for accuracy. So your boss seems to know a lot about statistics. Maybe they're like a senior data scientist, so they're asking some pretty good questions, you know, of your modeling here. But first, you should check the correlation between the metrics in the data set and reduce the dimension of the data with unsupervised methods. So that's what we're going to spend some time doing today. We're not just going to do regression. First, we're going to prepare the data. So using unsupervised methods. And your boss also wants you to test the parameters of the regression. And your boss wants to see the weights, also known as coefficients, produced by the regression. So our boss is pretty demanding, don't you think? Well, you know, it's an educational milestone. I just made this up and I said, oh, your boss wants you to do it. But so this is what the project is for today. It's to do all these things and we'll see how it goes. It's actually a lot to do. Maybe I won't get to all this in one stream. I'm aiming to stream for about 2 hours today. We'll see how this goes. So, importance to the project. Logistic regression is considered a good baseline for the accuracy of forecasts. It's also generally considered to be the most explainable method for predicting outcomes like churn. So that's kind of why we want to do this. Workflow. Using the techniques from fighting churn with data, prepare the historical data for regression. We need to do a few things. Convert the natural scale measurements to normalized scores. And this is called normalization or scoring. And it's a good step before you do a regression. Also, calculate the correlation matrix. Look if there are highly correlated metrics. And average together metrics for highly correlated metrics. That's not a very good sentence there. Sorry for the bad writing. My editor should have caught that too. But anyway, so we want to average together metrics that are highly correlated before we do the regression. That's step one. That sounds like a lot of work. It'll be easier than you think though. Then we want to use cross-validation to find the best value of a parameter for logistic regression. There's one parameter in logistic regression and we're going to have to find it. And then we're going to fit and save the regression model with the chosen value of the parameter. And then we're going to forecast churn probability for the current customers. So there's actually a lot of steps in this milestone. Like I said, I'm not 100% certain we'll do it all today, but we'll get to it. So that is the setup. Now you might be like, oh my God, this sounds like a lot to do. Fortunately, there is always some help at the bottom, which if you know the stuff in my book, I'd say just have at it. Don't look at the help. Sorry, clearing my throat there. So let's see. If you don't need the help, don't use it. But down here, there is some help. And it says, hint for step 1. There is a listing in the book 8.1, listing 8.1, prepare data from chapter 8. And it does all these things for you. All the data preparation steps for you, if we can learn it right, if we can use it correctly. So this is just showing a link to the code on GitHub. Oh, that's not a great way to look at it. Let's just go back to the milestone and we'll go into 8.1 prepare data. And maybe we'll come back here on the hint for step 2 as well. But let's get back to the code, which was here. I gotta close these things from last time too. I don't need the stats. Let's see, I don't need this one. Okay, what we do need is listing 8.1. That's what it said. Let's get back over here and find that. So the code is divided by chapters. And here's this listing 8.1 prepare dataset. Now this is a function that we can run, and it's going to do a bunch of steps. Stats, scores, grouping, finding groups, applying groups, and making a correlation matrix. Now I've got this in a slide too. Let's go back to the slide deck. So we're doing this churn forecasting regression, and I just walked you through all these without looking at this. So we talked about the project, and we looked at the milestone, and now we looked at the help and hints. So now I'm just like starting to do it. And the next thing is this slide, which summarized the data preparation for regression, which is pretty complicated actually. There's a lot of steps here, although let's see. The steps are actually listed here down the middle with a code that we have to run. And we already did listing 8.0, the dataset export. That's what I did in the intro. We also did the dataset summary. I showed you that one. Next, we have to do metric scoring. And then from that, we'll get some score parameters and we'll create the scored data set. I'll explain more about that in a moment. And then we'll go on to these other steps. So what is the metric scoring, which is the first step in the data preparation? Well, I did that. Yeah, this is what I'm showing you next. Sorry. Yeah, we already did the dataset export. Now we're doing the dataset summary and metric scoring. I showed you listing 8.1. And now this is what I want to show you. This is the concept of scoring shown here. The concept of scoring is that in your natural scale data of some metric or measurement of the customers, you have a lot of like crowding at the lower metric values. And then you also have a few people with very high extreme metric values. And the idea is to convert those metrics to scores, where the people are more evenly distributed and on an understandable scale or a common scale for all metrics. So we want all of our features or metrics to end up with 0 mean and 1 standard deviation and to be distributed more evenly. And that's kind of the idea of the metric scoring. So we'll go into the code to do it right now. Let me just see. Do I have to go to the next slide? No. All right, I should stick on this slide and go back to the code. So we want to run this listing, prepared data, which as I said is listing 8.1. But what we need to do is basically make a script to run it. So I'm going to go back and I'm going to make a new script for today's stream, which is I'm going to use it to call this and any other functions that I need to call through the stream today. So I'm going to go back up to like the top level, and I'll make a new Python file. I'll call it LiveProject regression.py. I'll go ahead and add it to my Git. Now I'm going to import that first listing. That's the first step for me. From, let's see, what am I doing here? It would be fightchurn.listings.chapter 8, because they're all organized by chapters. Import, what is it called? Listing 8.1 prepare data. Okay, so now now in this script, all I'm going to do is prepare the data. So I'll just say prepare, import from, wait, no, actually, I want to import this, and actually, that's the full name. Now I actually want to import, I think it's just prepare data. Okay, there we go. Now I've actually imported my function. So I just need to call it. And if you saw, I need to call it probably with a path, a dataset path, and also apparently a correlation threshold. This says group core thresh, which is going to be short for the group correlation threshold. I'll explain that more in a few minutes, but I'll just leave that at the default, I guess, for the moment. But what I do need is this dataset path. Now, if you recall just a few minutes ago, I was saving out my dataset, and I guess this was it. So this was the result of my last script that I ran at the start of the screen, and I still left it here. So this is the path that I need for my new script. So let's just put this in, dataset path equals, that's my local path. And I'll just put this in here for now. Let's see. And I guess we should just go ahead and try to run this, and you know, we'll get into the scoring code because that's the first part of the prepare data script. So let's see. Now I need to make a configuration for my IDE, which is PyCharm, and that's actually up here. So I'm going to go to Edit Configurations. And the easiest way to do this is always to copy your old configurations. So that's what I'm going to do. I'm just going to copy this configuration. I'm not even going to rename it yet. I'm just going to change this script path, hopefully. There we go. I'm going to change this script path. Ooh, that's a little ugly. Can we see a list, please? Thank you. Let's see. Let's see. Where's my new script? Did I save it in the wrong place? Let me just pause here and see where my new script is. Maybe I saved it at the wrong level. Apparently I did. Yep, I did. All right, that's my bad. I want to, like, can I move this up here? Or move it like this? Maybe I should just go to my Finder. Now I have to find this project. Let's see. Well, this is what happens when you're developing. You know, sometimes you want to save a script and you like save it in the wrong place. Happens all the time. So I just need to go in here, and here's my script. I don't want it to go in there because that's like where my package code is. All right, there's my little fix on the path. Now let's go back and fix my configurations. So this was my duplicated config. There we go. This is the one that I want. And now when I select it, it's going to automatically rename the configuration, like how I did that, or like how the program did that, I should say. And I'd better reopen it here. Okay. It's going to be messed up with, yeah, my Git is messed up. I'm just going to deal with that later, because I moved it after I told it to add it to Git, but whatever. All right, let's dig into preparing this data. And if anyone on the chat has any questions, comments, anything you'd like me to know or give more detail on, let me know. I'm going to try running this script and we'll get into the scoring function. Let's see, waiting for the program to launch. If anyone wants to tell me, how's the weather wherever you're viewing from? It's a foggy, kind of cold day in the Bay Area. So that's why I'm happy to be online. Even though it's June, it's pretty cold out there. So I hit my first breakpoint. That's good. Now I'm going to step into the prepare data function, which I already showed you. We actually looked at this dataset stats method before, so I'm just going to skip over it. And it basically ran those statistics, which we talked about before. Now I'm going to go into the scoring function, which is what's actually going to convert the data into the scored representation, which is normalized and better for regression, like I was saying before. So first we read the data set, which seems to have worked. And this will just be the same data set I showed earlier in the stream. If you missed that, we can do a quick view. Whoops. nothing to show. Okay, so you see it's a data set with one customer per row, if they churned or not, and a bunch. Now here, crucially notice the metrics or features are numbers like 26, 32, 100, 208. That's just like I was showing you in the slide, that you have a lot of people with a small value of the metric, then a few extreme outliers. So the data is not well distributed. So in making scores, what we do is first we make a copy, then I drop the churn column. We'll reattach it later, because first we're going to work with the numeric values of the features. This is actually going to reload the statistics that I ran in the last listing. So this is checking that the statistics are there, and it reloads those stats, and I'll prove it to you. We saw these statistics. If you're here at the start of my stream, we saw these. These are the same statistics we made before. So we reload those. Why? Because remember, we need to normalize the data to make it 0 mean and 1 standard deviation. So if we want that to do that, it helps to know what the mean and the standard deviation of every column is. So that's what we've got. Now for skewed columns, we're going to do some special stuff. And the skew refers to this same property I was talking about here. When you have a bunch of people, this is an example of a skewed metric or feature because it's only positive. Well, let's keep going through the code. So we're going to do a transform on the skewed columns. Let's actually see which columns are skewed. Well, we can look at the stats actually, and I'll just tell you like which columns are skewed. This is the skew. They're mostly all skewed. They're all skewed. A low skew of like 1 or 2 is not that high, but these skews are like 10, 15, 30, 180. These are almost all highly skewed. Not this one, I guess. And downloads per book is not too skewed, but even 5 is pretty skewed. So these are mostly pretty skewed. So we're gonna do a transform on them, which is another function. I'm going to try to step into it. Oops, this is on. I'm trying to step in, and I'm stepping into these. You know what I should do is I'll go into it this way, and then I'll just hit my breakpoint. So this is what we do in the transformation of the skewed columns. We take the log of 1 plus the data, and that means all these columns are going to be compressed to log scale, which means they're going to be small numbers like 0, 1, or 2. The reason I add 1 to the log before taking the log is because it might be a 0 value, and you can't take the log of 0. So this actually just goes around the columns. You can see it actually looping over the names of the metrics, and it takes the log of all the columns. And that's the transformation that we do for the skewed columns. I don't know if there are any fat-tailed columns. That's like a variation of skew that I go over in the book. It's when you also have negative values. Let's just look. I don't think any of these would come out as fat-tailed because none of them have negative values. So that's actually not really relevant. It's a slightly different transformation if you have negative values, but we'll skip that right now because we don't have any. Okay, the next step here is to find the mean values of the new scaled columns. So these mean values are now the means of the logarithms, and we can look at it here. So the means are now all small numbers like 0, 1, 2, or 3 because we took the logarithm of the original values. And now we're also going to take the standard deviation. And lastly, we're going to do the standard data normalization trick, which is to subtract the mean and divide by the standard deviation, which is what gives us the normalized values. So now if we look at the scores, it's a data set like our original data set. We can view it in the debugger. It has the same customer IDs on each row, the same features or metrics on each column, but they're all normalized to be small numbers close to 0, like -1, 2, it's kind of like -3 to 3, or like I showed in the slide, kind of like -5 to 5 is the broader range. And lastly, or almost lastly, we're going to reattach the churn column because we need that. I took it off because we do all those transformations. We don't want to transform the churn column, but we do need to reattach it. And then we're saving it. We're saving this out for further use. And let's see. I'm also saving these parameters. This is actually kind of important for later. What's this other little save here? I'm making a data set of the parameters that we used in scoring. So this is showing each metric, showing if it was skewed, if it was used the fat tail, and then what was the mean and standard deviation. And we actually need these later, you'll see, assuming we get to that in today's stream. But so that is really the scoring step, and that's kind of the end. We've just done the scoring, so if anyone has questions about that, I went through it really fast because this is all done in more detail, in the book. And now today we're trying to get through the LiveProject milestone, which means we did this scoring, and that was the first thing we had to do. The next thing we're going to do is this thing I call grouping, which has to do with reducing the dimension of the data set. What does reducing the dimension of the data set mean in English? It means having fewer columns, because your columns in the data are like the number of variables. So we're going to have fewer columns, and we're going to find groups and use something called a loading matrix. How do you find groups in data? We're going to look at an algorithm called hierarchical clustering or agglomerative clustering, which is a kind of weird word. And they work on metric scores. That's the first point. And we've already taken care of that. So we scored the metrics. So they're all mean 0, 1 standard deviation, and they have a good distribution. The algorithm works by basically greedy grouping. It finds the 2 most correlated metrics, and then it merges those by replacing them with an average of the 2. So you actually take the average of 2 metrics, and then you recalculate the correlation matrix, and you keep going. And I have another illustration of this, of what I mean by averaging groups of metrics with a loading matrix, because this is what the code we're going to look at is going to do. So let's say you have this toy data set. This is a dumb little toy data set with only 5 accounts, 5 observations, and 6 metrics. Now, what's wrong with that? There's more features than data observations, but this isn't real. Really, this data set would continue. But the point is, let's say we find that logins, reads, and replies are 3 metrics that are all correlated. Now, this is not the metrics from this data set that we're working on. This is just a toy example. If these 3 are correlated, we can average them in a group by multiplying them all by 0.33, 1/3, and summing it up. So if you average 0.4, 0.8, and 1, you get 0.7. And that would be the average metric for this first account for the first group. And then if we average minus 1.6 and 1.4, that would be the average for this second group. In this case, we achieve the average by multiplying by weights of 0.5, because that adds up to 1 and makes an average. And let's say for this last metric or feature, we don't want to group it. It's their score. And that one we just multiply through by 1. So this illustrates how, if you want to group together metrics and make an average of them, what you do is you create this matrix called a loading matrix, and then you do a matrix multiplication to get the right value. So it's a very cool way to do dimension reduction. It scales up to big data really well because it's just a matrix multiply, which is very efficient. And the hard part of this is actually kind of finding the groups. So there's it says quit when all correlations are below a threshold in this algorithm. And we have to get back to that because that is in an issue with our code. So this is this correlation threshold that I mentioned earlier. Note that I'm still kind of stopped. I've got my code frozen here at like my, at the step that I'm on. My correlation threshold is 0.55, but if you remember back from the instructions, there was an instruction for this. So that's why we read the instructions, hopefully. And it said average together metrics for highly correlated, those with correlation above 0.75. So now I actually have to go back and fix that in my code. What I need to do, I'm actually going to kill my script here. You know what I can do is I already ran these steps, so I'm just going to like comment them out just to make it go faster, a little bit faster the next time I run this. But I need to go back to, I need to close these things that I'm not using and go back here, and I need to put in the right threshold. Let's say correlation threshold equals 0.75 specified by the milestone. So now I want to use that as the threshold when I call this function. And now, let's see, I can undo this breakpoint, go back into here and put a breakpoint here. So now we'll go into the metric grouping function with the corrected threshold. And now I'll show you the metric grouping function, which, like I mentioned before, so that's we're going to go into this algorithm, finding the groups, hierarchical clustering. And spoiler alert is we don't really use that verbal, we don't write that algorithm. I just described an algorithm where you iteratively make a greedy cluster of two features, and we're not actually going to do that algorithm exactly. But let's see what we actually do. So now I'm in the listing, find metric groups, and the first thing I'm going to do is reload those scores that I already made. And if they weren't there, it would say you must run listing 5.3, blah, blah, blah. Okay, so I read the scores in, and just to prove it to you again, or in case you weren't here when we looked at this before, this is the feature set we're working on. We've got one customer per row, and we have these features which have been converted to scores, which means rescaled from their original values to the new ones. We have the outcome variable is churn is now on the end. Remember, we attached it in the last listing. We reattached it on the end in the last listing. So what do we do here? All right, we drop the churn column. We've seen that move before. We'll reattach it later. And now we are going to basically, this makes a list of the columns for later use. And now we're actually going to go into the function, the subfunction, which finds the clusters and actually does the hierarchical clustering. All right, let's go step in. Oh, great. Oh, damn it. Don't you hate it when you're trying to step into a function, but there's a function call on your line and you step into that instead? I'll have to set another breakpoint. Okay, now we're actually in the real function. So this is the function that finds the correlation clusters. Now, spoiler alert is we're actually going to use SciPy and a function called, two functions, the square form and the linkage and fcluster functions. That's actually 3 functions. And these actually do the clustering that I described for you. The one thing is they work in terms of dissimilarity instead of similarity, and correlation is a similarity measure. So by doing this, I'm just converting the correlation matrix, which I have here, into a dissimilarity matrix. Let's see. Can we look at that? Yeah, we can. This is a correlation matrix. We didn't talk about it, but we'll look at a correlation matrix in more detail in a minute. But the code calculated this correlation matrix, and now a dissimilarity matrix is just like the inverse, and that's what we need to run this algorithm. Hopefully that's not going too fast. If you want more explanation on that, speak up on the Twitch chat. Happy to go into it, but I don't want to get you bogged down. Now, this one function call, square form linkage, is actually what does the clustering. It doesn't actually do the clustering. Rather, it finds the distance between each feature in the similarity matrix. Uh-oh, am I crashing? That's bad. Uh-oh. This might turn into a debugging session. What's happening here? Yep, definitely crashing. Distance matrix K must be symmetric. Oh no, how could I have a non-symmetric correlation matrix? Ooh boy. All right, now it's a debugging session. So you definitely need a symmetric correlation matrix. And you know what I should do? There's definitely a problem with my correlation matrix. Let's take a look at it. And we can figure this out pretty quick. All right, I'm going to go to the output. I have a directory where all these outputs go. And these are the files we were just making. Well, I didn't see the correlation matrix, but let me just look at these stats again. Whenever you're debugging something with your data, a good thing to do is just check your data. And the stats that I saved in the previous script are a great way to do that. Now I think, let's look at, I think I already see the problem. Let me show you. All right, I think I see the problem here. One of my features is all zeros. That would definitely cause my correlation matrix to have nan, or not a number, in it. So this is actually my problem. So I'm actually going to have to do a quick re-extraction of the data set to fix this. Let's do it. All right, let's go to the last script we were doing was the dataset script. We're going to have to rerun this one, but also I need to fix my SQL, which, remember, was in chapter 4. It's the dataset SQL, and I was having that problem. It was with the metric like percent reading v2. I don't actually remember. That might have been a failed metric, but what I need to do is just remove this from my SQL and re-extract the data set. So this will actually be pretty quick. First, let's re-extract the data set. And then I'm also going to have to rerun the scoring step that I did before, but that will also be pretty quick. So let's see how long it takes to run that SQL. It's actually, you didn't notice when I ran it earlier in the stream, but it actually takes a minute or two because there's a decent amount of data in this data set. And it's doing those aggregations on all the columns, which is, the flattening of the data. So, all right, it didn't take that long, but it did take a noticeable number of seconds. Now I should have a data set without that row of zeros. Let's check. First, I'll close this set of stats. And that script also should have rerun my stats. So here's my new dataset file, and here's my new summary stat file. I'm just gonna look before I leap, make sure it worked. All right, this definitely looks like it worked. All right, so now all my metrics are good. Now I'll go back to the data preparation script. And I'm glad that happened, that little problem. I hope that's the only problem. But because that could definitely happen to you, if you have a bad metric, and you might get up to this step in the project yourself and be like, oh crap, why isn't this working? But always check your data. Someone actually asked me about this on LinkedIn recently too. Someone had a problem running a listing in the book, and it turned out to be they had zeros in their data set extraction. So this one, I'm just going to run it to my breakpoint, and it's going to rerun the stats and scores for me without us stopping. We'll just look at the output here. Whoops. Oh, wait, I'm running the wrong script. Sorry. I have to change the configuration. All right, go back to my regression script. Close up this one, close up this one. All right, this is it running the summary stats. Whoops. Now it should be, it wrote out the scores and the score parameters, and now I should be at my breakpoint. Hey, sorry, triple sneeze there. I think I hit the mute button just in time and my face turned red. Anyway, now let's see if the clustering works. Now I'm going back into this algorithm, into my find metric groups algorithm. I'll just step over these steps quickly. And let's go in here. Oh wait, actually again, this is a little problem with, no wait, oh damn it. Where am I? Oh, all right, stop. I missed the function I wanted to show you. All right, but it worked as far as I can tell. Let's not do this breakpoint and go into this one. I actually want to, I'm gonna put a breakpoint here. This is the function I wanted to show you. So let's actually try to get to that one and see that it works. But I think I fixed the data problem. So let's see. Missed the function I wanted to show you. Fun with debugging. All right, here I am now in the function I really wanted to show you. Let's just look at this correlation matrix. We didn't look at it closely enough before. If we had looked at it more, remember I looked at it, but I didn't scroll down. If I had done that, I probably would have noticed the bad data in the correlation matrix before. Now when we call this function, we get a valid hierarchy, which is a series of it's a array showing which ones are how close together. Now this gives the threshold for grouping, which was 0.75 correlation or 0.25 as a dissimilarity metric. And lastly, this actually does the clustering and returns a list of labels, which is the cluster assignment for each feature. So this is just a series saying that metric 0 is in cluster 5, 1 is in cluster 2, and they're kind of mixed up. So here are the ones in cluster 1, 11, 12. So this is the result of the clustering, and it's actually a little bit hard to read. Excuse me, which is actually what I'm gonna do in most of the rest of this script is just clean up the clusters and make a loading matrix from them, and then it will be easier to read. So this step just relabels the clusters, and I make this labeled column DF or data frame. I won't go into details, but it shows in a more interpretable way which are the grouped metrics. So now I can see that group 0 consists of these 4. Group 1 consists of these 3. Total highlights, highlight created, cross-reference term opened. Group 2 consists of these 2. Now it's not entirely interpretable, but we'll make the loading matrix out of it anyway. And I'm also gonna, I think, skip over making the loading matrix because it's basically just, let's look at the loading matrix. The loading matrix basically encodes those groups into a matrix, just like we discussed. So this now gives you a matrix that you can multiply to actually perform the averaging. So now we can see that the group 1 is again these 4 metrics, and these are the averaging weights we use to group them together. Now they're not exactly 0.25 or 0.33 as I mentioned, as I suggested earlier in the stream. There's a detailed explanation of that in the book. Again, I won't go into it now, but now you can actually see which metrics are grouped together. There's actually only 3 groups. This is a group of 4 metrics, this is a group of 3, and this is a group of 2. And then the remaining metrics are all individual in the loading matrix. But this shows you the result of the clustering. And we're going to save that loading matrix also. Now the last thing well, not quite the last thing, but the next thing we'll do is we will apply the loading matrix to form the average scores. That's what I was showing back in the slide deck. This is actually this step here of multiplying the data by the loading matrix, which we'll now do. That's not a really good illustration of a matrix multiplication, but it's kind of a conceptual illustration. So here, to apply the metric groups, that means we're actually going to group together the metrics that we found that we want to group, because we haven't done it yet. We reload the score data first, because that's what we're going to use. So the score data is our data set. It's got, let's see, around 33,000 rows. And now we drop the churn column like we're often doing, dropping it and reattaching it, which is the outcome column. Next, we are going to load the loading matrix, and that we saved on the last one. So this actually loads that loading matrix, and I can quickly prove it to you. This is the loading matrix we just made with the last script. Now we're going to use it. The first thing we do is convert the loading matrix into a Numpy array. That's because we're going to use it for some math. And the next thing we're going to do is we're actually going to, as it says here in the comment, make sure the data is in the same column order as the rows of the loading matrix. So I'm going to use the load matrix data frame index values to reorder the columns of the data that I'm going to run the grouping on. And next, I use the matrix multiplication function in Numpy. So this is the key step where I just grouped the data by making the averages according to the loading matrix. And what you can see is that the grouped data, if you look here on the bottom, it's only got 15 columns, whereas it started out with 21. I don't know if you can see that small font in your screen. I can see it by squinting at it. But so that I just actually achieved the grouping. Now all I have to do is reattach the churn column right here, just by setting it by assignment, and then I save it. And now that's it. I have now saved my group data. And the last step in this is to look at the correlations. And why do I do the correlations last? Well, I made it sound like in the beginning, you're going to look at the correlations and then you're going to do the grouping, right? But actually what I did is I did the grouping and now I'm going to look at the correlations. Well, the reason is I like to look at the correlations in order of the grouped metrics. I'll show you what I mean in just a sec. Here I load up the data that I'm going to work on. So again, this is my churn data, not the group churn data, but I also load my loading matrix. And then I'm going to do that trick again, excuse me, of reordering the columns of the matrix in the same order as the rows of the loading matrix. But remember, my loading matrix was ordered by group. So the first group came first and the next group came second. Now I'm going to take the correlation matrix using the simple Numpy correlation function. And if we look at it, it'll have this very cool structure, kind of. It's a little hard to see, but you can see the square of these first. It's actually easier to see in Excel. Let's go to Microsoft Excel. I'm going to finish running the script. It's just going to, say that it saved that. I'm going to go back to my output directory, and let's look at that correlation matrix. And I'll try to make it easier to see the structure. Here we are. So I'm going to, let's see, format this for readability, and highlight it so you can see the correlation structure more clearly. So now you can see the high correlation between these first 4 metrics that formed that first group. And this is a good way to look at correlation matrices, by the way. I like to look at them in Excel because you can freeze the columns or freeze the panes. And then when I scroll down, or over, we keep the labels. So now here you can see the second group of correlated metrics. They're not all highly correlated. These two aren't so correlated, but it's like these two are correlated and then the other two are correlated. So it ends up being, a kind of correlated group. And then this is the third group. These two are pretty correlated. Search made and search result opened. And that's a classic kind of correlation where you see two actions which are usually taken together are highly correlated. All right. I think that was a lot of work, but I believe we finished workflow 1. Use techniques from fighting churn with data. Prepare the historical data for regression. Convert to scores. Calculate a correlation matrix. Average together metrics that are highly correlated. And that's it. We've completed step 1. All right, and we're 1 hour into the stream. So I think there's actually a chance I'll be able to finish that today. But preparing data for regression is kind of a lot of work. Honestly, it's one of the reasons I think machine learning is so popular, and it should be popular because doing statistics is simply more work. What are you going to do? All right, now we say use cross-validation to find the best value of the C parameter for logistic regression. All right, let's talk about logistic regression a little bit. And I have some slides prepared for this. So we've gone through this whole process now, as I showed you. We did that last step, and now, I had this prepared slide to tell you like what correlation is. Let's skip that, and hopefully you knew what correlation was. Oh yeah, it's just the next slide here. Let's talk about what is regression. This is meant to give you an intuition of the regression model, which is that customers who are engaged become more likely to be retained, which is the opposite of churn. So customer engagement refers generally to all the things that make a customer happy, right? Using your service or product. And retention means not churning. 0 retention probability means 100% churn probability. So retention is the opposite of churn. And this just shows the relationship we expect to find between engagement and retention, which is that the more engaged a customer is, the more likely they are to be retained, but there's a diminishing returns for engagement. Similarly, the less engaged the customer is, the less likely they are to be retained. But there's also kind of this diminishing impact where the less and less engaged they are, it kind of has a reducing impact, which gives the overall curve an S shape. And this is a key concept of logistic regression. I say regression here, but I mean really logistic regression. So the regression model models the retention probability with this like a function like the one I said. Like you make this S curve of the engagement. Now the engagement of the customer is modeled with a multiplicative relationship where you take the metrics for the behaviors and you multiply them by a set of weights, which in regression is called the coefficients. So you have a linear multiplicative model for engagement. You multiply metrics by the weights which is also known as the coefficients. And then you have a nonlinear model for the churn retention probability from the engagements, which is like a sigmoidal model. So that's the model we're going to use. And what it said was we want to cross-validate to find the best value of a parameter. Now, cross-validation involves testing the accuracy, or AUC. AUC is a measure of accuracy. I'll tell you about it in just a moment. But we're going to test an accuracy measurement and see which one is the best. And that is the idea of cross-validation, which is going to be the next step we have to do. So let's see. This says I should just go to the listing. I was going to talk about the AUC. Maybe I'm not going to talk about the AUC. Sorry, not going to talk about the AUC. I thought I had a slide on that, but we'll do that maybe another time. Let's go to that listing now. We want to use listing 9.5. So I'll go here and look for that. All right, so here is my listing, 9.5 for cross-validation. And we need a dataset path, as usual. And then we need the number of splits for testing, I guess is the one parameter that we need. So let's see. I'm going to go back to the script I was working with because I already had a script. I'm going to close some of these actually. Let's close this, close this, close this, close this. Now the script I was running was actually here at the top level, LiveProject regression. Now I already did prepare data, so I'm not going to have to do that again, but I'm going to use the same script. So I'm just going to import my new listing. Churn, listings. Now it's chapter 9. I want listing 9.5, import, cross-validate. Now I also need a new dataset path, actually, because now I have to use the scores. So to do that, let's see, I'm going to use the Macintosh trick of copying to get the path. So I copy here from my Finder. This is a good trick if you're on Mac OS. Paste into a terminal, and here I've gotten my path. Oh wait, but that's the wrong one. I better copy paste the right one. I want, whoops, no, this one. I want to get this one, the group scores, I believe. I don't want to copy paste the name. I want to get the whole path. All right, here's the path for the scores that I've run through the grouping algorithm. So I'll put those in a string now. Pretty sure that's what I need. I should like double check that. Because sometimes my listings here actually look for, oh wait, actually, no, I actually don't want the group score path because this is going to add the group score path to it. All right, back up. Ignore what I just said. Use the old path. So what I'm going to do is just run cross-validate. And we will use the dataset path. And I had to give it a number of splits, and I'll just say 5. I mean, just picking that kind of randomly. So now we'll delete this line. That was all a mistake. Sorry for that. I'm going to comment out that line because we've already done it. And let's just go to the cross-validation function. In fact, let's go into the cross-validation function and see if this works. So again, cross-validation is something that's kind of complicated, but I've already set it up for you in fighting churn with data. And if you understand how this works, you can just use it. I mean, the idea of this live project is to use the code in the book, not write it from scratch. So let's just see if this works. So here I'm in my cross-validation function now, I think, hopefully. And I've got my dataset path. Now this is going to do a little data preparation for me. Let's go in here and see what it does. It checks for the scores. So I've actually got it set as a default to look for the group score data. I didn't remember that I had that taken care of. That's why I was checking that path. So it checks that it's there. It loads it. This is now the new data set. I don't know if we actually looked at it, which actually has the groups. The grouped metrics instead of the original ones. So you see here I've got metric group 1, metric group 2, and metric group 3 for the first couple of features. And then I have my individual features. So you can see they're grouped and they're all scored because they're no longer on the natural scale of those metrics. So the next thing I do here is I just split out the outcome and call it Y by convention. If we're modeling this as retention, which it is, we convert it from churn to retention for the outcome by subtracting the outcome from 1. That just flips the zeros to ones and the ones to zeros. And it's nice to do your logistic regression on retention as the outcome instead of churn, because then when you get your coefficients, positive numbers are good. Because remember the multiplicative model that I mentioned on the slides earlier here, and especially, well, yeah, we'll just leave it at that. That's the reason we're flipping the sign, so that now retention is the outcome, and now it returns the two, the data and the outcomes separately, which is what we need for the sklearn algorithms we're going to use. Now this class controls splitting the data. I'm not going to go into details on that. This gives you, this dictionary, score models, tells it we're going to calculate a metric called lift and a metric called AUC. Lift is kind of a marketing metric, so how good your classifier is at predicting churns based compared to random guessing. And the AUC is the area under the curve. I kind of just mentioned that briefly. I'm going to skip that too, unless I get a question on the chat. I'm going to assume you know what these metrics are. So we're actually going to create the logistic regression object now that implements that algorithm. Now I'm going to test these parameters called C. I actually didn't include an explanation of the C parameter, but the C parameter sets how big the coefficients can be, or how big the engagement weights can be. It's not exactly a maximum value. It's actually a penalty function for large weights. So the larger we make the C parameter, the larger the weights are allowed to be. And the smaller we make the parameter, the smaller the weights will be, but it's not literally a maximum value. I kind of explained that more in the book. All right, I'm gonna skip over the next part is where we actually run the algorithm. Cross-validation is pretty quick for logistic regression, fitting 5 folds for each of 9 candidates, totaling 45 fits. Now, if you watched my previous stream on machine learning with XGBoost, you would have seen it took a lot longer. I've already run the fitting, and now, well, no, there it is. Now it's done. Okay, so it took that took more than 10 seconds, which is probably only because I'm streaming at the same time. My computer is so slow when I'm streaming. Right. So now I've got the result of my regression, and I guess we can look briefly at what that result data frame is. It's each of 9 versions, each with a different value of the C parameter. It then tells me what is the lift and the AUC. So here you can see the mean test AUCs are around 7.2. They're actually all very close to each other. 7.25, 7.26. They're all very close to each other, which is often the case, actually, that changing the parameter doesn't affect it too much. Let's see. So this function does a test on the weights, and I'm gonna make a plot of the test and show you what we did in just a sec. There's more details on this, of course, in the book. The regression test plot plots different things in the regression. One is the mean AUC, and another is the mean lift at each. Here, let me bring in the plot as we create it. So that's the mean AUC. This is the mean lift. And the other key thing that this prints is the number of weights that are non-zero. Now this is the third plot, which is kind of the most important one, because this shows how many weights you get at each, at each value of the C parameter. And basically what we want to do when you pick the value of the C parameter is get the number of weights you want to minimize the number of coefficients because it makes your model simpler, but you don't want to hurt the accuracy. So let's actually get out of here, and I'll go to show you the results like up close. So this is that chart we just made. Please open, here it is. So this shows, as you can see, there was very little difference in the AUC across these. You can kind of just, if you squint, tell that it's maximum around the middle. Here you can also see the lift. It looks very flat. Here you can see in the last chart, you can see the number of coefficients kept in the model does go down as we reduce the C parameter. Wow, even having just 2 coefficients, and it doesn't really reduce the AUC that much. This is kind of interesting. Let me open up that regression result again. This is the result that we were seeing. Well, this is our old correlation matrix from before. Let me just close that so it doesn't keep opening up. Don't save, we looked at that enough. So this is the result that we got out of the regression. And let's see, a little bit hard to read here, but if I wrap these texts, then I'll see this is the AUC metric that I'm trying to optimize. And it looks like, let's see, my best values are here, where I'm getting 0.7268. And then it does start going down just a little bit, but we do want to pick the best, right? So I think we want to get the least number of features that still has a good AUC. So I guess it would be this one. Let's see how many features that has. So that's 0.02 or 0.04 are our best values. And they have 10 and 13 features respectively. So actually, I'm going to go with 0.02. So I'm going to reduce the number of features, or the number of coefficients, from 14 to 10 by using 0.02 for the C parameter. And you can see that by doing that, I'm actually getting a slightly better AUC. So it's actually worse. This is interesting. It's actually worse AUC if you use all the features. It gets a little bit better, and then it gets worse again. And that's a pretty typical thing to see on a real data set. I don't know about the lift. The lift is a less reliable metric. Let's just take a quick look at, it looks like lift actually gets a little bit better. Oh, yeah, but like I said, lift is not a great metric. It's really better to use AUC for this type of thing. So so that's basically what we're gonna do. Let's go back to this. So use cross-validation to find the best value of the C parameter for logistic regression and the historical data. The best value minimizes the number of non-zero weights while improving or not harming accuracy. So now we figured out our C value. And question, how does the accuracy of logistic regression compare to the accuracy of XGBoost? Well, it just so happens that if I look in this folder, I should be able to find the XGBoost cross-validation result from here. Yeah, so this will just be a cross-validated result. And this is what you would have if you did milestone 1. So let's see. Here is the much larger cross-validation we did on XGBoost. And I'm going to wrap these texts so that we can see. Get over to the mean test AUC. Oh, 0.749. So this is definitely better. If you probably can't read that. But made it a lot bigger. So you can see on my XGBoost, I got 0.7488 accuracy. And that's in comparison to 0.7268. So I got like a full 0.02, 2%, or I don't know if that's the right, 2 percentage points of AUC. AUC is not really a percentage, but Anyway, so 0.02 increase in AUC is actually nothing to joke about. That's not bad. So it shows our XGBoost model was better than the baseline. So I've now accomplished this milestone 2. Now it says fit and save the regression model using the chosen value of the C parameter. Also save the weights the regression assigns to each metric coefficients. All right, let's go back to the help here. It says, hint for step 3, you should be able to use listing 9.4 regression with a C parameter. Well, once again, let's just stick to the project and I'll go to the code. So now I need to call listing 9.4 to run the regression with a specific value of the C parameter, which I chose. So here's this one. Again, it takes a dataset path and a parameter. So let's actually, I'm gonna have to start like, let's see. Well, the simplest thing is just to keep commenting here. So I guess I'll just do that. Now I need to do from fightchurn listings chapter 9 listing 9.4 import regression C parameter. So now we're going to run that one. Whoops. Regression C parameter again with the same dataset path. And now, okay, so what did I say my best value was for the C parameter? Back to the data. I said it was 0.02, right? So I'm going to use 0.02. And that should get us through this next part of the milestone. All right, so I'll put a breakpoint in here so we can watch what this function does, and then I'll just let it go. All right, first I'm going to run that prepare data step again, just like we did last time. So I won't go back into that, but you can see my data here. It has those grouped metrics. Now I'm going to make a logistic regression object from sklearn and pass in my C parameter value, which was 0.02. And that's really all there is to it. What I am going to do is I am going to save a summary of the regression. And this is my own custom summary function for a regression. And one thing that I do in my own regression summary is I calculate something that I call the impact of a 1 standard deviation difference in the feature, which is an interpretable measure of how much difference it makes in the probability. I'll show you that, like, we'll just save this out and then we'll look at it. Let's see, this is doing, this is making a data frame of the coefficients and saving them. So it's saving my summary, which is also going to help finish this milestone, because I'm supposed to look at the coefficients to finish the milestone. And here I'm actually going to save the regression model. This one is simpler. I'm actually just saving a pickle. So if you're not familiar with pickle, it's like the standard way to save Python objects. So this does the pickle dump and saves it out. And lastly, we're going to save some predictions, which means we're actually going to use this model to predict churn. We're predicting on the historical data, which is not exactly what we need to do, but it's just a nice thing to look at. I'll skip over that one because we're going to do some more predicting later. I'll just let this one run out now. And let's take a look at what was saved, because it said, let's see, back here it said, save the weights the regression assigns to each metric. Then question, what is the most significant metrics contributing to churn or retention? How do these findings compare to the machine learning model? So, let's see. This is my summary. of the model written out as text. Sorry about that, having a lot of throat clearing issues today. So this is what I saved out from the regression. And this column shows you the actual weights in the regression. And I'm just going to, well, I'm going to convert them to numbers in a slightly more legible way. It might need a few extra decimal places. Some of these are kind of small. And let's also look at the, I'm going to put some colors on these values to pop out what's really going on. So this column is what I called the retention impact before. So what you can see here is, wow, by far the most important feature is the distinct number of products that the user purchased. And here what the retention impact means is that if you are one standard deviation above average in the number of products, then you have a 20% higher chance of being retained, which is actually really big. All these other things actually don't make too much difference. Let's see, this metric group got zeroed out. These metric groups, cross-reference term opened and highlight created, is slightly negative. These are also slightly negative. Downloading ebooks is actually positive. Let's see. Wow. What else made a difference? Not dashboard LiveBook linked opened. Huh, that's interesting. That actually made a difference. So if they use dashboard LiveBook links, they have a 1% or one standard deviation above average, you get a 1% increase in retention. And that will increase for people who are more standard deviations above average. But it's really showing strongly that the biggest predictor of retention is having a lot of products already. And that kind of makes sense, honestly. Now, the question was, how do these findings compare to the machine learning model, right? Fortunately, from the previous stream, I have the explanation of the machine learning model. Let's see. Shown here with the SHAP plot, S-H-A-P. And here this is showing also for the machine learning model, the number of products is by far the strongest metric. And it's showing that this must be churn. So this is predicting churn. The higher of the number of products, the lower the churn. The second most influential is the ebook downloaded, which I think we also found being pretty influential. Let's see, ebook downloaded. Now, other influential metrics in the regression were wishlist item and LiveBook login. Let's look for those. LiveBook login, also influential in the machine learning model. And maybe if I move this over, we can see both at the same time. Yeah, here we go. Now we can see the regression coefficients and the shape plot, shapely additive explanations at the same time. It's kind of interesting. You definitely see a more complicated picture in the machine learning model. Yeah. Still though, the same at the very top level. Distinct number of products, ebook downloaded. Let's see, the total event metric, I think, got grouped. So total events got grouped into metric group 1, and it actually did not end up being used at all. LiveBook logins, probably also grouped with something. Where's LiveBook login? Oh, here we go. Oh no, that one. Okay, that one actually was a significant feature here. So it seems like kind of the explanation from the regression and the machine learning is, not too different. All right, let's go back to this. Optional, make a visualization of the weights showing what contributes most to retention versus churn. Well, actually, I have already done that because here it is. This is my visualization. I guess I could, really get crazy and make a chart. Like this would be another visualization which would show, which metrics contribute the most to retention and churn. So that would be a reasonable way to satisfy that requirement from your mean boss who keeps asking for so many tests and analyses of this data set. Cool. All right. What's next to do? Forecast the churn probability for the current customer data set. First, prepare the current customer data for regression following the procedure you used on the historical data. All right. This is going to be a little bit more work. No, it says next, make the forecast using the saved regression model. Make a histogram, compare it to the one from the XGBoost model. All right, so first prepare the customer data for regression following the procedure you use on the historical data. Now, if you were here earlier on the stream, this is actually kind of involved. I'll go down here to the help, hint for step 4. Use listing 8 for rescore metrics. Okay, that's the first thing. Well, the first other thing is to make sure I have the right current customer data, because remember, I had to fix my data before. Let me start with that. So recall that I had to, I'm going to close these regression listings. I had to re-extract my data set. Because, so there's another SQL to give you the current customers, which is like the old one, the regular data set, but it's using all the customers at the last date available. That's why it's current. I mean, really this data is like 2 years old now, but come on, it's an educational project. So the one thing I probably have to do here is I have to make sure these metrics are exactly the same as the ones in the data set that I fit the model with. And because I was just messing around with them, remember I deleted the metric, one of these metrics. It was like some percent change v2 that I was testing in an earlier stream. So now I just need to make sure that I'm really using exactly the same metrics here. I'm going to do that just by copy pasting from one dataset file to the other. Now I'm going to go back and rerun my dataset script, which was this one. And I did this in previous streams, the version which will make the current data. So I'm just going to go true, false here, and as you can see, it's basically just running the same old SQL listing function, but using listing 4.6, which should be, let's just double check. 4.6 should be the current customers. 4.5 is the data set, 4.6 is current customers. Okay, so let's go back and run the data set listing. See how that works. And as we observed earlier on the stream, it takes a noticeable number of seconds to actually, extract a data set like this. It's kind of a big SQL. Good time for me to get some coffee. Pretty quiet on the chat today. Guess no one has any questions. All right, so I saved my current customer data set, and it should have the same columns as my original data set. Sorry for that, dropping the mic there. Now it says use listing 8.4 rescore metric. So let's take a quick look at that one. This is explained more in the book, but this listing basically, let's see, retraces the steps of the scoring that we did earlier, all the way here. So rescore metrics. It's like the score metric function that we did earlier in the stream. So let's go to the script we're using for regression. And now I'm going to use, I'm going to import the new script. Oops. Churns. Now we need to get that chapter 8 listing 8 for rescore metrics. So now we'll comment out this one, and we will use rescore metrics, dataset path. And I guess let's just get into it. So what this is going to do is it's going to redo all the steps that we did. Maybe I should go back to that. It's going to redo all the steps that we did earlier with the data preparation. I'll remind you with this slide. It's going to redo all these steps, but the key thing is it's going to redo the scoring and the grouping. Well, it's going to redo the application of the groups, but it's not going to redo the calculation of these parameters. So if you were here on the stream when I did this part earlier, when we did the scoring, we saved out parameters, and we found the groups, we saved out the loading matrix. So now when we rescore, we use the old parameters and the old loading matrix, rather than, redoing it. So that's what we're going to do now. Let's see. Let me go back to my regression script. And this should pretty much get us to it. Let's give the debugger a second to catch up. Okay, so here I am. So I pass in my dataset path, and I have these helper functions. This one says reload churn data. It's a general helper to reload one of these files. You might notice that I end up saving a lot of little files while we process the data. And this reloads one of them. So this one reloads our loading matrix. You might remember it from before. If not, here it is. That was the loading matrix we had earlier, just proving it to you. I'm also going to reload these score parameters. These were the parameters that I used when I was normalizing, which ones were skewed, what the mean and standard deviation I used were. And lastly, I'm going to load my current data. The current data is that data that I just downloaded. And it's like the original data set, but no outcome, no churn, because the idea is these are all currently active customers. So they haven't churned, right? That's the whole point. We're going to try to save these customers. All right, so now I first do some checks. Whoops, am I failing? What happened? I was just going to say I do some checks and I'm failing in my I'm failing in my assertion. So my score data frame does not have the current, the right columns. All right, I've missed a step here. Thought this was going to be easy. Let me look at what's happening here. Let's see. I wonder if I have them in the wrong order or no. Let's see. Data to rescore does not match. So actually the order doesn't matter, but I do need to have the same column. So I might have screwed something up with like what the features are here. All right, back into debug mode. Hopefully this won't happen to you when you did it. Let's just take a quick look. All right, I'm gonna actually go through the debugger and look at those things before I get to the assertion. Let's see, and I tried I tried re-extracting the data using the same thing, so maybe something went wrong. So score df.index.values. This is the score parameters, and these are Yeah, I've got 21 of them, from reading own book to total time reading. Now my current data, what are these ones? Whoops, did I not reload it? Oh, I have to run that line first. Load the current data. Current data.columns.values. Now how can this be different? Starting from reading own booked to total time reading, there's 22 of them. Oh, this one still has percent reading. I thought I fixed that. Okay, I thought I re-extracted the data and took care of this, but I thought wrong. What happened when I did my dataset fetch? LiveProject current customers. Is that the right name? Let's see. Current customers. Is that the right name? I'm wondering if I have like an older version. Let's see. When we do this rescoring of the metrics, what do I do? I think it's just supposed to be current _ current. That's one problem. Yeah, I think I've got an error in my path. Let me just try renaming. I think it's supposed to be like dataset current. Yeah, I think I was reloading. Whoops. Oh. Let's see. Well, let's find that other one, because there's an old LiveProject dataset current, which is from April. I don't want to use that one because I don't know. I trust more the one that I made today. But I need to give it the right path name or this isn't going to work. So this should be LiveProject _ dataset current. And I'm going to fix that in my old script. Like, this was actually the problem, I think. I think we have to put in this name. Anyway, let's try the new name for the file and see if that fixed it. Going back to my regression script. Let's see. Loading the score df, loading the data. Now let's check if I have the right columns just by running this. Oh, it's still not working. All right, let's look at the current data. What am I doing? Still doesn't look right. It's still got percent reading v2. What did I do here? All right, look at your data. That is always a good thing. LiveProject dataset current. I'm actually just gonna look at it by opening it up because I'm getting a little bit annoyed here. I thought I removed that feature, percent reading v2, and I keep having trouble with it. But here it is. What happened? All right, going back to the dataset extraction. I'm just moving too fast here, and this is like, it's good to see me, I think it's good for y'all to see me like screwing this stuff up, because this is really normal as a data scientist. You're just like, I thought that I was doing the right SQL. I should be running SQL 4.6. Actually, I need to go back here. It's actually 4.6. It is current customers. save extension. Let's just call it. Is this where I give it? Maybe this is what I need to give it the right extension. What happens to that extension? Just going through my own code here because I actually don't remember what it does. And let's just look at that sequel and make extra sure there's no longer... Oh, wait. Oh, the percent reading v2 was still there. What the heck? I thought I got rid of it here. Oh, man. All right, well, I think this is what I need to do. Now I'm really going to rerun the data set. And this time I'll make sure. So looking at the sequel, now there's no more percent reading v2. Man, this bug has taken me like 15 minutes. Very embarrassing, but you know, I'm a grown-up. I can take a little embarrassment on the live stream when my own code doesn't work. And this is a fine time if anyone has like data science-y questions while we're waiting for this to run. But this is one of those quiet on the chat days. All right, now I have actually correctly, I hope, saved it. So I think this needs to be named dataset current. Oh God. Well, let me throw out the one that I saved earlier. Now I'll rename this one. All right, now let's try running that regression script again. Let's see. Still trying to get running, reloading the current customer data set, having some issues, making sure, but it's important to make sure that the features in your current customer data set are the same. So I screwed up by not making sure of that before. This is the third time I've been here. Let's check this assertion. See if I finally got it right. All right, so I finally have the right features in my current customer, but this is an important check because this can really go wrong. Now I'm also checking that my loading matrix has the right features. All right, now it finally worked. So now I can actually redo the scoring. So that took like an extra 10 minutes there while I debugged that. But you know, that's how real, data science goes sometimes. Now I'm going to transform the skew columns using the list of columns. Whoops, that's not the function I want to step into. Boy, this is the pain of debugging. It's much easier if I go into this one and set a breakpoint. So here I've got the series of which are the skewed columns, and it's actually like most of them, as you might recall from earlier in the stream. So for all those columns, I'm going to take the log of the metric plus 1. That's the transformation that I do. And then I'm also going to do that fat tail transformation. But remember, what's different now is that I'm using this data frame rather than figuring out which ones are skewed or fat-tailed on the new current customer data set. I use the same results as before. And similarly, when I scale the data, I'm going to use the previous the means and standard deviations that I got before. So these are the means and standard deviations from before. So this is where I subtract the mean, divide by the standard deviation. And then I'm going to save these scores out. That'll take a moment. So now I've saved the scores out, and now I'm going to redo the grouping. But again, instead of finding a new loading matrix, I'm just going to use my loading matrix. So I'm just passing in the loading matrix, same loading matrix as we had earlier, if you missed it. And so now I have my scaled data. I sort it to have the right order of columns. That's crucial. Before applying before doing the matrix multiplication, you got to make sure the columns are in the right order. Then this is my group. Well, I multiply by the scaled data by turning them both to NumPy in this one liner. And that actually does the grouping. And now I saved those grouped and scored results. All right. And what does save segment data do? I'm trying to remember. What does this one do? Let's see. I guess this is just saving about, what are the groups in the data. A little extra output there. All right, so now I've actually achieved this key next step that I have my, I actually have my group data that I can run the rest of the algorithm on. So back to the help. I was going to use listing 8.4 rescore metrics, and that's what I've done. So I've rescored the metrics using the same approach as before. And now I'm going to use listing 8.5 churn forecast on that data. So let's go back to the script. Hopefully I'm done extracting the data. Took me a few tries to correct that one. Wow, I have lots of code open now. Closing these things up. So now I need to do from fightchurn listings chapter 8. It was listing 8.5 churn forecast, which uses a method of the same name. So once again, I'll just call churn forecast. Probably need a dataset path, and I probably also now need my model name. So if we go into this, I have to pass it the name of my model, and the default is just log reg model. But actually, I used my own version of the log reg model that had the C parameter set. So I'm actually going to have to use this string here. I'm just going to copy that out, the log reg model string. And let's see. Actually, I could do this by, I think, let's see. To make it explicit, I can actually use a formatted string and put in the value of my, well, actually, I should make a constant for this. Regression C param equals 0.02. Whoops. And I will use my constant here, even though I'm not going to rerun the regression. But I'll put it here, and I probably need to give it a formatting string. I think this would be like 0.2f would be the correct formatting string to get to 0.02. I'd better put a breakpoint here, just to make sure that I'm doing the right thing. So this is going to run my churn forecasts if I've done this all correctly. So yeah, let's let it rip, see how it goes. All right, here we are, letting the ID launch. All right, now I'm going to go into the churn forecast function. Let's see. So first step, let's see. So what did my model name end up being? Logreg model C0.02. Just checking that. Looks right. I think. LiveProject dataset logreg model. I'm actually not so sure. Maybe do I need that string dataset in there? This might not actually be okay. LiveProject. Oh no. It looks good. Looks good. Check the assertion. Oh no, not good. Not good. All right, I have an error in my path. Damn it. What is it supposed to be again? Boy, flailing here on the path. It should be dataset path dot replace. So it's going to replace the very end of my dataset. What is my dataset path? Now here, let's go back and figure this one out. What is my dataset path? Should just be this standard LiveProject underscore dataset.csv. Actually not quite sure. Does anyone on the Twitch chat see what I'm doing wrong here? My dataset path is LiveProject underscore dataset. My regression, it's logreg underscore LiveProject dataset live underscore model. All right, let me debug this again, and I'll look at it more closely. I think I just have a dumb error in one of my strings, and annoyingly, these things can take a while. Always embarrassing to have dumb mistakes on a live stream, but let's try to sort this out. Step into my function. So now my dataset path, the pickle path, it thinks is supposed to be what? Users blah 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 LiveProject underscore dataset underscore logreg underscore model. LiveProject underscore dataset underscore logreg underscore model, right? C0, 0.20. It's an error in my formatting string. That's the bug. Remember up here, I used 0.2 in my formatting string. I think this is my bug. Yep. So this is setting how many decimal places I'm gonna keep. Even though my value of the C param would have been fine with 2 decimal places, it looks like I'm using 3 decimal places as the standard. So that should hopefully get me past this bug, and we'll be able to look at some actual, forecasts. Let's see. Churn forecast, pickle path, assert OS is path. All right. Got my path right. It was just a formatting string. Okay, so now I'm going to open my logistic regression model file. That's easily done. And now I'm going to try to reload my current data. Let's hope this one works. It's another one where if I have the path wrong. Okay, that worked. So my current score data frame is loaded. In case you missed it before, this is what that looks like. Each row has an observation of a customer, and each column has a feature or metric that's been scaled to the appropriate scale. So now I will actually make the predictions. This is the easy part. So logreg model predict proba is the function that I want. This is what actually gives me predictions. Now I have my predictions. What do the predictions look like? Let's take a look. It's actually an array of just 2 columns. The first column is the probability, I guess, of retention, and the next column is the probability of churn. I'm actually not so sure about that. It might be the other way around, but they add up to 1. It's the reciprocal. So this is actually my prediction data, and yeah, it looks like the first column was the churn probability. The next column is the retention column, is the retention probability. All right, now we save those. Save it and out. And the last thing we'll do is also make a forecast histogram, which was part of the assignment. So let's get into the histogram code, which is pretty easy. It's very easy using matplotlib to make a histogram. Let's actually watch it appear. Just use plot.hist, and now I'm using the churn probability. So this is the histogram of the churn probabilities. Let's see, there it is. All right, well, a lot of people have a pretty high churn probability. And then there's this kind of like long tail of people with much lower churn probabilities. After this, I'm just annotating the plot. Histogram of active churn probability. Add a little grid. And I think that's it. I'm also going to save out the histogram in a data frame. That's something in a CSV, really. I temporarily make a data frame and then save a CSV. And that way I can look at the histogram, you know, more easily in Excel or some other program like that. But so this is my my histogram. Let's close up this one. This is the histogram of predicted churn probabilities. And I think in this assignment, I was supposed to compare that to the ones from the XGBoost model. That might be the last thing I'm supposed to do. Okay, make forecast using the saved regression model. That's what I did. Make a histogram and compare it to the one from the XGBoost model. Okay, the XGBoost model, fortunately, I have it saved somewhere from my last stream. If I just look, let's see, it would have been maybe this. Oh yeah, here it is from the XGBoost model. Now this is interesting. You've definitely got a lot more going on in the XGBoost churn prediction. Kind of interesting here. You can see that the regression model kind of has a simpler distribution for, that's the one on the left. I have it here in parentheses, regression. It's a similar, I mean, overall, the churn probability, the average is probably similar from the two models. But you can see the regression model is giving more people this highest probability of around 80%. The XGBoost model has fewer people at that peak, as you can see, because this is only 10,000. And then it has this other interesting peak here. It's actually a bimodal churn probability distribution, which I think is because the XGBoost model will make a lot more complicated rules. I mean, that's the real difference between regression and XGBoost. Remember, back to the regression. Let's see. No, I was going to skip this one. We want to look at this one, I think. This is showing you, remember, the regression is a simple linear model of engagement. And then it does a kind of sigmoidal curve to give you the actual default probability. But that is why we can only really have simple, you only will tend to see a simple distribution of churn probabilities from the regression model. But on the XGBoost model, I should have gotten that, the Shapley plot. Remember that the Shapley plot, I should have it here in my recent, what does this one say? There we go. Here's the Shapley feature explanations. This shows actually some pretty complicated stuff going on. Like you see a lot of these features where a low value is neutral and like high values are both good or bad. That's what you're actually seeing here. In the XGBoost model, this is almost the only feature which is really monotonic in its influence. All these other features in the XGBoost model have more complicated influences. And that's why, remember, on the XGBoost model, we got 0.02 higher in the AUC. I don't think do I still have those open? I guess I closed those up. But we got a higher AUC, and we have this more complicated, churn distribution going on in the XGBoost compared to the regression. So it's more accurate, more complicated. So I think that kind of covers. Oh, hey, Dipperdon12. One of my familiar faces showed up. You're kind of at the end of the stream here, though. I've been going for like 2 hours, and I'm just about done with the milestone. In fact, I think this is it. I just did step 4. It says deliverable. In this milestone, you made a logistic regression model for churn, generated predictions for an out-of-sample dataset. To demonstrate your work, submit the histogram of churn predictions and either a table or visualization of the coefficients of the regression. So to get the, the Manning certificate of completion on this, you would want to turn in a chart that looks somewhat like this one. And remember, I had mine in Microsoft Excel. I guess I closed it up already. Let's see if I can find my summary of the logistic regression. This has the list of coefficients, and it has a little, chart. I just did this kind of like quick and dirty. But this is what, the other part of what you would hand in for this milestone. So, yeah, I think that kind of completes the milestone for me. Now, where was I? I kind of like ditched my slide deck a while back. Oh, yeah, you can watch the recording. Oh, yeah. Oh, it's Sunday in Melbourne. Right, you're in Australia, I remember. Well, I'm glad you slept in. I would not encourage, it is not worth it to get up early on a Sunday. And I'm sorry that it's such an awkward time. But, So this is basically, let's go over these summary slides. Yeah, I have this summary of the logistic regression outputs. That was an important point here. Coefficients. So we have the coefficients. That was these guys, right? Then we had predictions on the data set to look at the distribution. And that's what we were looking at here. These are my predictions that we're looking at. And the other thing, remember, we also saved a model pickle for future use. And that you will find with the outputs. It's a very small file too. Where is that? If you look at this, it's only 1 kilobyte. It's a very small file to save a logistic regression model. So let's see. And what else are we doing? Oh, we did the current customer predictions. Yeah, I kind of skipped this slide and I just explained it while I was doing it. And we did the dataset current. Oh yeah, I had all these slides prepared that I basically ignored. But we did all these steps, and then we did the submit your work part. Yeah, and I'm just at 2 hours, which was kind of my goal. So I'm gonna wrap it up. Let's see. This is the summary from today's stream. It is: fighting churn is about targeted interventions, improvements, engagements, support, pricing, making all those great changes. Regression is classic statistics, but I hope I showed you it's still very powerful. Remember, the XGBoost machine learning model was only a little bit more accurate. I mean, in practice, you want to get that accuracy, but it wasn't like night and day. It was like, a reasonable improvement. So regression and classical statistics are still very powerful. You make a linear multiplicative model of the behavior to get the engagement. That's multiplying the coefficients by the features. Then there's this S-shaped relationship of engagement and retention, the sigmoid. And then you get weights and coefficients, which are very interpretable representation of the per behavior contribution to reducing churn. Now, we did this also scoring data, which is like grading customers on a curve. And that's just something you have to do kind of like for regression. I didn't really go into the details of why that's important, but I'll give you one clue. We didn't really talk about this, but we can interpret the coefficients here and see that this is the most important feature because we scored all the features so that they're all on the same scale. If the features had not been on the same scale, you couldn't just look at the coefficients and see which ones are the most important. So that's just one of the reasons, we do that. So grouping data is for interpretability and making your regression more robust. Interpretability, I think it helps just to see which are the features which are closely related. And we could also try doing this without grouping. That would actually be interesting. Maybe we can do that as like a quick live hack at the end. See if sometimes your regression model can be more accurate without grouping. So maybe we'll do that real quick. And rescoring, we need to rescore data for forecasting. So we did that. And you have to use the parameters from the fitting phase. Let's see. I'm actually curious now. Since I already wrote this script, it's actually pretty quick. If I want to redo some of my analysis without grouping so much, if I set this correlation threshold higher, like at 0.95, there probably won't be as many groups. And we'll see if it let's just see. Sometimes grouping, it improves interpretability, but it may hurt accuracy. Because remember, we found that regression was a little bit less accurate than XGBoost. I just want to try this real quick and see if with a higher correlation threshold, we get a more accurate model. And because I already wrote all this code, this should actually be pretty quick, just to run the data preparation and cross-validation, and we'll see what happens with the loading matrix. This will be just a really quick thing, because overall this stream went pretty well, no serious screw-ups. All right, that's doing all the data preparation right there. Now it's doing the cross-validation. While it's doing the cross-validation, I want to look at the new loading matrix and see if it actually, it still actually found one group of metrics. I was trying to make it not group anything. But this is the loading matrix. You can see it still grouped a few metrics that must be very, very highly correlated. Because I remember I set that threshold for the correlation a lot higher this time. Let's see. I just want to look at the correlation matrix really quick to see how correlated those three metrics are. And if we zoom in, you'll be able to see this. Yeah, these three metrics are all like, oh my god, yeah, they're all more than 0.95 correlation. So still very high correlation. So I'm going to leave those grouped. That's fine. But how did my cross-validation do? Now remember, we had like 0.72 AUC on the grouped metrics. Let's just see if it makes any difference at all. And if it's comparable to the XGBoost. All right, got to zoom in again here. So this was the output of the cross-validation. If you didn't see it before, these are the values of the regression parameter that I tested. And now let's look at the new accuracy that we get. Oh, it's not that much better. It's a little bit better. I don't think I saved the result last time, but it was like 0.727. So we actually got a little bit better by grouping fewer metrics. So I kind of got like half a point of AUC. So that's like the price of your interpretability there. A very small, this is 0.73. It's still not as good as the XGBoost model, which, do I still have that one open? No, I don't. But anyway. All right, well, that was the last thing I just want to do. That was just a little bit for our interest. I'm going to switch this back to the 0.75 correlation threshold, which I was supposed to be using. And this is really the entire script for this milestone, because it's really just, you know, reusing all the code from the book. That's kind of the idea of these projects, is that you can it shows you that with a real data set that's just a real bunch of customer data, you can use these techniques and get your answers about churn pretty fast. Cool. All right. Well, if there's no other questions or comments on the Twitch chat, I will mention that there is a book. I wrote a book, which is where all this code comes from, where you can get more details on all the code and never pay full price. You can get 40% off the book if you use this discount code. Although, if you have Amazon, that 40% off might just like kind of cancel out your delivery fee. Now, this is the link for the project I've been working on. It's the LiveBook data project from Manning. And it's a live project. It's kind of like a mouthful. It's a live project based on the LiveBook data. And again, here's a discount code. If you actually want to get the data and go through this code yourself, definitely use the discount code. And this is how you can keep track of me and what I'm doing. Please follow me on Twitter. I'll give you updates on my streams, Churn. I'm pretty much like a Churn commentating service. If you want to keep up with what's going on in Churn, follow me on Twitter and I'll tell you all about the latest trends in churn rates and, you know, who has higher churn, Netflix or Disney. It's all in my Twitter feed. Okay, today's music was Leak Beats Lo-Fi, what we've been listening to. It's a popular stream on Spotify and also here on Twitch. Thank you, Leak Beats, for providing the background music today and for not giving me copyright problems on YouTube, which many copyright-free streams do give you issues, even though they say they're copyright-free, but Leak Beats is really copyright-free. All right, thank you for watching. And I'm going to thank a few people in particular right now. Those are the new followers, like Modus Vivendi 1. Thank you for following. I don't know if you're out there. Hope you joined me today. But I don't have too many people to thank, but I got to give a shout out to my few followers, the proud, the data nerds on Twitch. Siobhan11, thank you for following. Hope you see this stream and see me give a shout out to you sometime. Maybe right now. So thank you to another cool Twitch handle, Never to Been to Here. Thank you for following me, Never to Been to Here. I hope you see this shout out from me sometime. Pleasure to have you on Team Data here on Twitch. Just a few more of these. Thank you to, hey, I already did that one. Not working mini feed replay. This is a feature of Streamlabs, which is the software I use for the streaming. All right, come on. UC Voyager, thank you for following. That's what I was trying to get to. Thank you, UC Voyager. I wonder if you're at University of California, because when I see UC, I think University of California, because I live just a few miles from UC Berkeley campus. Why UC Voyager again? Oh, God. I'm trying to show someone else. I have just a few more thank yous, so bear with me if you're out there. Come on. Replay. Keita Rose, thank you for following. The replay feature on Streamlabs OBS just kills me sometimes. But thank you, Keita Rose, for following me. And we've just got one last thank you to... Thank you, Miserisk or Miserisk. Risk? I don't know. Anyway, you tell me how to pronounce that one. Well, anyway, thank you all new followers who joined my stream in the last couple of weeks. I know I've been kind of silent on the streaming. I apologize, but my day job kicks my butt. I really am a professional data scientist. I manage a team, and it's a lot of work. So streaming was just not happening recently. And also my health hasn't been so great. That's another one. Let's not go there. Not always as healthy as I'd like to be. Anyway, my normal stream schedule is to stream on Saturdays, 2 p.m. my time. That is early in the morning for Australia. Sorry for that. But I don't like streaming too late on a Saturday too, because, I got other things to do here on a Saturday afternoon. All the videos go up on demand on YouTube, so if you know anyone who prefers YouTube to Twitch, or even if you prefer watching YouTube when you're on the go, great place to find all my videos. And my next stream, that's actually a